Hello my dear friends, welcome to my YouTube channel. I am feeling very humble right now. There are 1000 incredible subscribers like you who have subscribed my YouTube channel. I would like to thank you for the following me on my journey. I know that the 1000 subscriber is nothing to brag about compared to the other YouTube subscriber. But the feeling of helping out people and receiving beautiful comments to encourage me to continue is really something that keeps me engaged and puts a smile on my face. I have got 1000 subscribers a month to post cause of some personal issue, but I will be come back with the more longer and better Silvaco TCAD videos soon. I have decided that I will share my every Silvaco TCAD code and modeling code with you. Those who are listening my video, send me the personal message on Telegram or WhatsApp or through email. I will share my contact detail in the description section. I will tell you how to get my all the Silvaco TCAD code or modeling code. Please send me the personal message. I will explain you how you will get all the code. Thanks a lot. Today we will talk about the dual material gate nanoscale tunnel field effect transistor. Some of the people called me asking about dual material gate TFET structure, and the most importantly they want to know which work function should be high, either auxiliary gate or tunnel gate. Please listen my video carefully. I will explain everything in this video. Dual material gate nanoscale tunnel field effect transistor. A dual material gate in a tunnel field effect transistor is to optimize the on current and off current. It will increase the on current and reduce the off current. And it also optimize the threshold voltage and also improve the average sub-threshold law. In my earlier video, I have explained how to calculate the threshold voltage and the average sub-threshold law. If you don't know how it can be calculated, please follow my previous video. A dual material gate also reduces the short channel effect, especially DIBL, drain induced barrier lowering effect. There are a number of advantages of using dual material gate in comparison with the single material gate. We demonstrate that if appropriate work function are chosen for the gate material on the source side and the drain side, the tunnel field effect transistor shows a significantly improved performance. We apply the technique of dual material gate in a double gate tunnel field effect transistor to show an overall improvement in the characteristics of the device, along with achieving a good on current and excellent average sub-threshold law. This is the dual material gate nanoscale tunnel field effect transistor. This is the dual material gate. We are using different work function at the source side, that is called tunnel gate, and the drain side, that is called auxiliary gate. Actually, we are using the different work function at the drain side junction and the source side junction. Comparison of single metal gate and dual metal gate structure. The single metal gate with a higher work function has a higher on state current than the single metal gate with a lower work function. However, this higher on state current is accompanied by a correspondingly higher off state current, leading to a higher sub-threshold swing and a greater power dissipation in the off state. If you are increasing the on current, then the simultaneously off current is also increases. It will increase the power dissipation in the off state of the device, and it will also increase the sub-threshold swing of the device. Practically, we have to need lower sub-threshold swing. While the single metal gate with the lower gate work function has a lower sub-threshold swing and its on current is low. One advantage of using higher work function is that it will increase the on current, and the another advantage of using the lower work function is that it will improve the sub-threshold swing, so that the dual material gate structure is able to combine the benefit of these two structures. It will improve the on current and simultaneously it will improve the sub-threshold swing of the device. The dual material gate is able to combine the benefit of these two structures. It has an on state current equal to the single metal gate with a higher gate work function and an off state current equal to that of single metal gate with a lower gate work function. Whether the auxiliary gate work function is high or tunneling gate work function is high, it will depend upon the type of the dual material gate TFET structure. Either we are using the P-type or N-type structure. In a P-type dual material gate TFET structure, the tunneling gate has a higher work function as compared to auxiliary gate. This leads to a higher potential difference between the source and the channel, thus reducing the tunneling length and increasing the on state current. Next question is tunneling gate length. If the length of the tunneling gate is small in comparison with the auxiliary gate, the surface potential in the off state depends completely on the auxiliary gate work function, which is lower than the tunneling gate work function. As the auxiliary gate work function has a low value, the potential difference between the source and the channel is lower in the off state, thus reducing the off state current. Lower work function at the auxiliary gate side helps to improve the off state current while reducing the off state value of the drain current. Next, we will talk about N-type dual material gate TFET structure. In the P-type gate TFET structure, the tunneling work function is higher than the auxiliary gate work function. But in the case of the N-type structure, the tunneling gate work function is lower than the auxiliary gate work function. I will explain what is the benefit of taking low value of the tunneling gate work function as compared to auxiliary gate work function. In a N-type dual material gate TFET structure, the tunneling gate has a lower work function as compared to auxiliary gate. I am showing two structures. The first one structure, the above structure, is when the device is in off state. Off state means VGS is 0 volt and the VDS is equal to maximum is equal to 1 volt. And the lower graph will show when the device is in on state. VGS is 1 volt and the VDS is 1 volt. First we will talk about when the device is in off state, VGS 0 volt and the VDS 1 volt. When we are talking about the device is in the off state, we will talk about the off state current. When we are talking about the device is on state, then we will talking about the on state value of the current. Let's start when the device is in off state. If the work function of the tunneling gate keeping fixed at low in the off state, that is equal to 4.0 electron volt. First I have taken the fixed value of tunneling gate work function at 4.0 electron volt and work function of the auxiliary gate is increased. It will be increased from 4.0 electron volt to 4.8 electron volt. Then what would occur? The tunneling width increases and the band overlap decreases on the source side. You can note down that this is the valence band of the source, this is the connection band of the channel. The point here is noted that if you are increasing the auxiliary gate work function from 4.0 to 4.8 electron volt, the band will move in the upward direction. This will reduce the band overlapping at the source side. When the work function is 4.0 electron volt, the band is more overlap as compared to when the work function is 4.8 electron volt at the auxiliary gate. This will lead to a considerable reduction in the off state tunneling probability and help to improve the off state current. However, at higher work function on the auxiliary gate, band overlap begins to appear on the drain side. If you note down at the drain side, conduction band of the drain and valence band of the channel, this one. If you are increasing the work function, the band will more overlap. This will increase the tunneling probability, or we can say that it will reduce the tunneling junction width. You can note down here is that if the tunneling junction width on the drain side becomes small, tunneling can occur in the off state. This means that if we are increasing the auxiliary gate work function, the source side, the band will be less overlap, but at the drain side it will be more overlap. It will increase the ambipolar current because the junction will become more overlap at the drain side and will increase the tunneling probability, so that the ambipolar current is increased. But if you are watching at the source side, the tunneling probability reduces. This means it will reduce the off-state current of the device. Next, we will talk about the on-state current. This is the second figure. In the on-state, as shown in the figure, the increase in the auxiliary gate work function does not change the band diagram significantly. The band overlap begins to decrease when the auxiliary gate work function is greater than 4.4 electron volt. Since the reduction in the band overlap is over that section of the band diagram where the tunneling width is already large, the tunneling probability is not affected significantly. Simply, from this diagram, you can note down that if you are increasing the auxiliary gate work function, then there is no difference in the overlapping at the source side as well as drain side. In the on state, I have explained you why we are taking the auxiliary gate work function is greater than tunneling gate work function. It will help to reduce the off state current of the device. When the device is in off state, VGS is equal to 0 volt and the VDS is equal to 1 volt. Next, I will explain you why the tunneling gate work function is less than auxiliary gate work function. First, I have explained why we have taken the higher value. Next, I will explain why the tunneling gate work function is lower as compared to auxiliary gate work function, in which we have fixed the value of the auxiliary gate work function approximate 4.0 electron volt, and I am changing the tunneling gate work function value. Again, the above figure showing when the device is in off state, and the lower figure will showing when the device is in on state. Next, we analyze the impact of tunnel gate work function on the characteristics of dual material gate double gate tunnel field effect transistor. As the tunneling gate work function is decreased, keeping auxiliary gate work function fixed at 4.4 electron volt. In the off state, there is no band overlap on the source side when the value of the tunneling gate work function is 4.0 electron volt, this one, and hence the off current is expected to be the quite low. If you are increasing the work function to up to 4.8 electron volt, then the overlapping will take place. This will increase the off state current of the device. Simply, if you are taking the value of the tunneling gate work function is more than auxiliary gate work function, this will deteriorate the drain characteristics in the off state. It will increase the off current value. Next, we are talking about when the device is in on state. With the reduction in the tunnel gate work function for 4.8 to 4.0 electron volt, the band overlap increases and the tunneling width decreases, leading to the significant increase in the tunneling probability on the source side. In the on state, reverse processes take place, or we can say that if you are reducing the work function at the tunneling gate, this will help you to improve the on state current, while reducing the gate work function value, we are reducing the tunneling width and leading to a significant increase in the tunneling probability. When these bands will overlap, conduction band of the channel and the valence band of the source will become overlap. The tunneling width will become 0 and it will help to increase the on current of the device. While taking the tunnel gate work function is lower than the auxiliary gate work function, we note down that in the off state, the band overlapping will become increased. This will reduce the off state current, and in the on state, while taking the tunnel gate work function lower value as compared to auxiliary gate work function, the band overlapping will increase at the source side. It will help to improve the current in the on state and help to reduce the current in the off state value. Next, how to define dual material gate in Silvaco TCAD. Dual material gate are present in which form? It will also depend alloy or blend. If it is alloy, then we have to determine the mole fraction and according its band gap and electron affinity. If it is blend, we have to look for phase composition of blend also. There are two ways. If it is alloy, choose any metal in the structure editor and directly define metal name in the electrode section. Second, define work function of the metal parameter. You can use the metal name directly in the code or you can use the value of the work function. First, use common is equal to gate for both of the contact after the contact statement. One more point to note that you have to use common is equal to gate. If you are using the dual material gate structure, you have to mention common is equal to gate in the code statement. I will explain you how. To define dual work function, you need to define two electrodes with different work function. Electrode name gate and gate 1. We have taken two. First for the tunneling gate and second for the auxiliary gate. We have to define the position also. Next, we have to define the work function in the contact statement. Contact name gate work function, for example 4.0 electron volt, and the contact name gate 1, this is the auxiliary gate, for example work function 4.8 electron volt. You have to mention common is equal to gate statement. Why you have to define this statement common is equal to gate? If you don't apply this statement, then the different voltage will apply at both auxiliary gate work function and the tunneling gate work function. To apply the same voltage, you have to use this statement common is equal to gate. If we are dividing the total gate length into three different gate sections, then you have to mention common is equal to gate statement in every gate 1, gate 2, gate 3 work statement. My dear friend, this is end for today. If you like my video, please subscribe my channel and give comments in the comment section. Thanks for watching.